Okay. Now, one more question is there in our classroom workbook, question number 12. Our classroom workbook, question number 12. For a linear time invariant system, what is the question is, for a linear time invariant system, input is R of t, output is C of t. For a linear time invariant system, input is R of t, output is C of t. For a linear time invariant system, input is R of t and output is C of t. Now, what he is asking is, the question is, now the input is passing through a block. Now the input is passing through a block having a gain of e power minus s. Now the input is passing through a block having a gain of e power minus s. This is the question. Now the input is passing through a block having a gain of e power minus s, then it is applied to LTI system. Then it is applied to LTI system. Then it is applied to LTI system. What should be the modified output? Now the question is, now the input is passing through a block having a gain of e power minus s, then it is applied to LTI system. What should be the modified output? What should be the modified output is the question. Yes, definitely now the input is passing through a block and then it is applied to LTI system. Now definitely some changes in the output. That's why he is asking what should be the modified output. What should be the modified output? Yes, this is the modified output. Now similarly here, now this is input R of t, then I just have this linear time invariant system. Now having some impulse response, let us assume this is some f of t. I am assuming this is f of t. For better analysis, then I go to the frequency domain. Now the Laplace transformation of R of t is R of s. Now the Laplace transformation of R of t is R of s. The Laplace transformation of f of t is f of s. This is LTI system. Now this is output C of s. So what is C of s? Now the C of s, can I write like this? The output C of s, which is equal to R of s into f of s. Now output C of s, which is equal to R of s into f of s. Right. Now the question is, now the input is passing through a block having a gain of e power minus s. Now the input, which is nothing but R of s, is passing through a block. Now the input is passing through a block having a gain of e power minus s. This is in S domain, therefore I take everything in terms of S domain. Then it is applied to LTI system. Then it is applied to LTI system. Now this is the LTI system. Now I just assume this LTI system impulse response I am assuming as some f of s. Then it is LTI system. Then what should be the modified output? This is the modified output. Modified output C of s. Now see here. Now this is input R of s. Therefore this is input R of s into e power minus s. Therefore this is e power minus s into R of s. Then this is applied to an LTI system. Then what should be the modified output in time domain? The question is asking modified output in time domain. First we will see in frequency domain. Therefore, C of S, which is equal to e power minus S into R of S into e power, all are in frequency domain, e power minus S R of S into F of S. Therefore, this is the modified output. This is the modified output. But this is in frequency domain, but we want in time domain. Therefore, C of S, which is equal to e power minus S. What is R of S into F of S? Can I write like this? This R of S into F of S, which is nothing but C of S. We can write like this. R of S into F of S, this is nothing but we can write like this is some C of S. But this is in frequency domain, modified output in frequency domain. But the question is asking modified output in time domain. Modified output in time domain. Now listen, first you can understand the question itself. Now this is question number 12 in workbook. Now for a linear time invariant system, input is R of t, output is C of t. Now he is not mentioning any F of t, I am just assuming. Input is R of t, output is C of t. Now the input is passing through a block having a gain of e power minus S. Then it is applied to LTI system. What should be the modified output in time domain? Actually that is the question. Right? What is the modified output in time domain? Therefore, if it is in frequency domain, this is the correct answer. But he is asking modified output in time domain. Therefore, now see here. Now, if see here, this is one formula. F of t is a positive signal. If F of t is a positive signal, now this positive signal is delayed by an amount of a units. This is a positive signal, therefore u of t multiplied with u of t. This is delayed by an amount of a units. This f of t is a positive signal is delayed by an amount of a units. Therefore, then whose Laplace transformation is? Whose Laplace transformation is? This is time shifting. This time signal is delayed by an amount of a units. Then whose Laplace transformation is e power minus as into f of s. E power minus as into f of s. Now this is the time shifting, then this positive signal in a time domain is delayed by an amount of a units. Therefore this positive signal is delayed by an amount of a units, then therefore this is e power minus as into f of s. Then see here, now if you observe this one, the modified output in time domain, then for if you apply the Laplace transformation inverse, then if you apply inverse Laplace transformation, if you apply the inverse Laplace transformation, if you see here, this is e power minus as into C of s. What is a here? This is e power minus a is 1 into s. E power minus as into C of s. What is a value? A value equal to 1. E power minus a equal to 1. Therefore, if you apply the inverse Laplace transformation, therefore, the inverse Laplace transformation of C of s is C of t, which is equal to inverse Laplace transformation of C of s is C of t, but here a value is 1. Therefore, this time domain signal is delayed by an amount of 1 unit, C of t minus 1, and this is positive signal u of t minus 1. Therefore, this is the modified output. This is the modified output in time domain. Now this is question number 12 in your workbook, and for that this is the solution for that. Okay, take this one. Okay, these are the few uh, problems of the basics, and now we go for some concept of this particular control system basics. Now in that, now you already have some basic experience, which is nothing but now where are the poles location, how to find time constant, now how to find order, how to find frequency of oscillations, now when it is stable, when it is unstable, what is the definition of stable, what is the definition of unstable, and you already have an experience of all these things based on our previous sessions. Okay, now for the extension of that previous sessions, then I just give a few basic concept of this particular basics of the control system, which is useful throughout our remaining portion of the subject. Now what I am doing is, now I am giving a different poles location in S plane. Now what we studied so far is, we studied only two cases: when the pole lies on the left hand side stable and pole lies on the right hand side unstable. Now we will take all the combinations, then what happened, the system behavior, response, time constant, we will find all the parameters. Now one concept, if you remember, based on the poles location, if the poles are having a real part or imaginary part, or both, whatever it is having, if the pole is having both real part and imaginary part, only real part or only imaginary part, whatever it may be, the impulse response in time domain directly, the impulse response in time domain is directly some constant into e power real part into t sine or cos imaginary part into t. Now this is the impulse response in time domain. This is the impulse response in time domain. This is the impulse response in time domain, k into e power real part into t sine or cos imaginary part into t. This is the impulse response in time domain for any poles location, whether it is left hand side, right hand side, it is having only real part or only imaginary part, or it is having both. Only this concept, this is one shortcut method. You can easily find what is the impulse response, what are the terms present in the response, you can easily identify. That's what I'm saying. If it is having only real part, your response is having only real part, take this exponential term, forget about this sine or cos term. If your pole location is having only imaginary part, take this portion and remove this particular exponential portion. Therefore, sir, here sine or cos, which I have to be taken, then which we want to be taken. Whether it may be a sine or cos, it is not a problem for us. Here it is not a phase difference. How much is phase? All these things are not important. What is important? What is the frequency of oscillations present in the response? In the response, is presenting any oscillations or not? That oscillations are present means this sine or cos is coming, otherwise this term is not coming. Therefore, whether it may be taking a sine or cos, it's not a problem, but what should be the frequency of oscillations present in the response is only important here. Okay, anyway, now this shortcut value will give the same result or not, you can verify for the different types of problems. Okay, now I'm giving you different problems. Now most of you are thinking that now this is lies on right hand side of S plane. This is lies on right hand side of S plane. Therefore system is unstable. Then most of you are thinking like this. Yes, then if it is lies on right hand side of S plane, system is unstable. This is the wrong answer. Now sir, previously we are talking about left hand side stable, right hand side unstable. Yes, previously we are talking about left hand side stable, right hand side unstable. Actually, I am also saying correct. I am also agreed. But what is left hand side? What is right hand side? What is this fellow? This is a 0. Whether 0 is lies on the right hand side or left hand side, whatever it may be, the zeros will not play the role of the analysis of the control system. The control system complete behavior response is completely depends upon pole's location, but not the zeros location. Don't judge the stability or response or behavior analysis by looking at zeros location is a wrong answer. That's why this unstable is a wrong option. Understand or not? Therefore, now whether 0 is on the right hand side, left hand side or anywhere, this is not important. The important one is where is your closed loop pole. Your closed loop pole lies on which side, then only you can decide the system stability only from that pole's location. Sir, this is the pole's location. What is my question? My question is, if the pole's location is given in S-plane, now you tell me all the parameters of the control system. That is the question. Okay, for all the questions, once the pole's location is given, then you want to answer for all the questions. Okay, all the parameters. So we start with from the first parameter. Now, how many closed loop poles here? 1, 2, 3. If there are 3 closed loop poles, therefore order is how much? Order, which is equal to 3. There are 3 closed loop poles, order equal to 3. Now, system, first you decided the system. Now where is your pole? Your pole lies on the left hand side of S-plane or not? Then forget about the zeros. The zeros lies on the right hand side or left hand side is not a matter, because the zeros are there in the system, but it is not there in the response. You already have an experience. Therefore, your pole completely lies on the left hand side. Therefore, system is stable. Closed loop control system is stable. Now, if your closed loop control system is stable, you can find the system time constant. What is the system time constant? The time constant is nothing but here more number of poles. 1, 2, 3. There are 3 poles. If a more number of poles, therefore which pole you have to be choosing? You have to choose a dominant pole. This is the dominant pole. This is the dominant pole. This is the dominant pole. Therefore, what is the time constant? Negative of reciprocal of real part of dominant pole. The real part of dominant pole is -1. Therefore, time constant is 1 second. Now, these poles are having any imaginary part? No. These poles are having only real part, no imaginary part. If there is no imaginary part, therefore the frequency of oscillation is 0 radians per second, because there is no imaginary part. There is no imaginary part. There is no imaginary part, therefore the frequency of oscillation is 0 radians per second. Now, only real part, there is no imaginary part, frequency of oscillation is 0 radians per second. Now the response is decided only from the pole's location, because the response consisting only poles. And I am already saying that now this is the dominant pole. The overall closed loop control system response is decided by the dominant pole. What is the overall closed loop control system response? The overall closed loop control system response is decided by the dominant pole. The dominant pole is on the negative real axis. Therefore, the response is exponentially decaying. The response is exponentially decaying. Now, is there any oscillations in the response? No. The frequency of oscillation is 0 radians per second, and from the pole's location also we'll say the frequency of oscillation is 0 radians per second. Both are matching. And the response is follows the input. The response is follows the input. Therefore, system is stable. And already decided the poles on the left hand side of S-plane, system is stable. Now see here. Now from here what we can conclude? From here, from this particular problem, then what you are saying? Now what we are saying is, now irrespective of location of the zeros, the control system complete behavior or complete analysis is decided by only closed loop poles but not the closed loop zeros. That should be the note you have to be considered for this particular problem. What is the note you have to be considered? Irrespective of location of zeros, the closed loop control system complete behavior, complete analysis depends upon only closed loop poles but not the zeros. Why? Because order you decided from the poles location, stability you decided from the poles location, time constant you decided from the poles location, frequency of oscillation you decided from the poles location, response you decided from the poles location. Therefore, irrespective of location of zeros, the closed loop control system complete behavior depends upon closed loop poles only. That point we have to be identified while solving this particular question. Okay, note down. Okay, and here also you can say, now what is the response in term? Some constant into e power, what is the real part? That's what this is the shortcut method saying, no? The impulse response in time domain, which is nothing but some constant into e power, real part. What is the real part? But there are n number of poles are also having real part, but all these things are not important. Only the dominant pole is important. Therefore, real part of dominant pole, what is the real part? -1 into t. Is there any imaginary part? No imaginary part. Therefore, then you have to consider only this. So, this is the impulse response in time domain directly for that particular problem without doing partial fraction, all these things. Some constant into e power, real part into t. That's why the response is exponentially decaying. Therefore, some constant e power real part equal to -1 into t. The response is exponentially decaying. Now, like that, you can easily identify the impulse response in time domain directly. If the question is not asking all these things, just he is giving the poles location, and he is asking what is impulse response in time domain. What is impulse response in time domain? Then all these things are not required directly. The impulse response in time domain is nothing but some constant e power. What may be a real part? The real part of pole, but there are n number of poles. Consider the dominant pole. That's it. If there is imaginary part, consider this one. Otherwise, you forget about the imaginary part. Now I am talking about the impulse response is nothing but I am assuming by default which input? Impulse input. Therefore, which response? Impulse response, because this is the theoretical analysis I am doing. Then we move for the next example, next concept. Now, if the question is like this. Now see here, if the question is like this. One pole is at here, -1. One pole is at here, -2. One pole is at here, minus 3. Then what happens? All r lies on the left hand side. System is stable. Now the problem is happening when if the pole is here. If the pole is here, then what happen? Now see here, if the pole is here, what happen? Then you just observe. Then total how many poles? 1, 2, 3, 4. So there are 4 poles. Therefore, first of all, the order which is equal to 4. Now, if any one of the pole is on the right hand side of a plane, system is unstable. Unstable or not, if you have any confusion, then you can write like, if you can see like this. You can easily understand with this. Now, this behavior is exponentially decaying. Now, this is some exponentially decaying because this is 1 by s plus 1, some constant into e power minus t. The response is exponentially decaying. Now, this is 1 by s plus 2, which means that some constant into e power minus 2t. Therefore, the response is exponentially decaying. Now, this is 1 by s plus 3. Now, the response is some constant into e power minus 3t. The response is exponentially decaying. Now, this is some partial fractions which we are taking. For example, now see here. Now, plus, now what happened here? Now, 1 by s minus 1. Therefore, some constant into e power plus 1 into t, and the response is exponentially increasing. The response is exponentially increasing, and the overall response is also the overall closed loop control system response is also exponentially increasing. No sir, I am not interested on this closed loop control system response is increasing or not. How I can understand means, then you can easily understand like this also. See here. Now what about this? This is some constant into e power minus t, and plus this is some constant into e power minus 2t plus some constant into e power minus 3t. Now see here. Now this is plus some constant into e power plus t. Then at t tends to infinity, what happens? This is the response. If you substitute at t tends to infinity, now this is the response at t tends to infinity, limit t tends to infinity. Now e power minus infinity is 0 plus e power minus infinity is 0 plus e power minus infinity is 0 plus e power infinity is infinity. Therefore, which is equal to infinity. Limit t tends to infinity. Now the response is limit t tends to infinity. The response is infinite. Then the system is unstable. Limit t tends to infinity. The response is infinite. System is unstable. Limit t tends to infinity. The response is infinite. Then the system, which is nothing but unstable. Now see here. Now such that's what I'm saying. The response is exponentially increasing. System is unstable. If any one pole is on the right hand side of S plane, system is unstable. Therefore 4 poles, order equal to 4. System is unstable. System is unstable. Now time constant, what about the time constant? So we cannot find the time constant, so time constant we cannot calculate. The time constant we cannot calculate because system is unstable. Now is there any imaginary part? No, all the poles are having real part, no imaginary part. Therefore frequency of oscillation is 0 radians per second. There is no imaginary part. So then what is the impulse response in time domain? The impulse response in time domain, which means that, now see here, the impulse response in time domain, which is nothing but directly you can write the impulse response in time domain, you can directly now, which is equal to k into e power real part. Now real part means which real part we have to take it, this one, this one. If the pole is lies only on the left hand side, you take the dominant pole, but if the pole is on the right hand side also, therefore this is dominating because this is infinity plus 0 is nothing but infinity. Therefore this is the response is exponentially increasing. Therefore the overall closed loop control system response, the overall closed loop control system response, which is nothing but exponentially increasing, exponentially increasing. The overall closed loop control system response, which is nothing but exponentially increasing. And here is also observed there is no frequency of oscillation. Yes, here is also there is no frequency of oscillations. There is no frequency of oscillations present in the response. Now this is the overall closed loop control system response for this particular problem. That's what we can understand from this particular problem. If any one of the pole lies on the right hand side of S plate, system is unstable. Even if it is 100 poles on the left hand side of S plane, but there is only a single pole on the right hand side of S plane, system is unstable because whose effect is dominating compared with that particular poles. Take this one. Now see here, if only one pole lies on the left hand side of S plane, that is very simple. If it is only one pole lies on the left hand side of S plane, you tell me only one pole, therefore order equal to 1, order equal to 1, and left hand side system is stable. Time constant, which is nothing but 1 second, minus 1 by minus 1, which is nothing but 1 second, and no imaginary part, therefore frequency of oscillation is 0 radians per second, and the response is exponentially decaying. That everything we know that, okay, because there is only a single pole now, which means that now only one pole. Anyway, we'll see this one also. Order equal to 1, only one pole. Now left hand side system is stable. So now we can find the time constant. Time constant is nothing but minus 1 by real part of the dominant pole, which is equal to 1 second. No imaginary part, only real part. Therefore frequency of oscillation is 0 radians per second. Then what is the impulse response in time domain directly? The impulse response in time domain directly, which is equal to C of t which is equal to some constant into e power real part. Yes, what is the real part? This is the real part minus 1 into t. No imaginary part. The impulse response C of t, which is equal to some constant into e power real part. What is the real part? Minus 1 into t. Sine or cos imaginary part. There is no imaginary part, therefore there is no sine or cos term. Therefore this is the response, then the impulse response in time domain, which is exponentially decaying. Yes, this is the impulse response in time domain, which is C of t, which is equal to some constant into e power minus t. Therefore the response, which is nothing but exponentially decaying. This we already know that. This we know. Everything we know. Now see here. This we know that, okay. But what I am interested is, I am not interested on this. Now I am interested on this. Now see here. Then what happened? Repeated poles on the negative real axis. Then if it is a repeated poles, how many poles? 2 poles. Therefore what is order? There are 2 poles, 1 and 2. Therefore order equal to 2. Now the pole lies on the left hand side. Therefore system is stable. Now what is the time constant? Negative of reciprocal of real part minus 1. Therefore time constant equal to 1 second. Then is there any imaginary part? No imaginary part, only real part. Therefore there is no imaginary part, only real part. Therefore frequency of oscillation is 0 radians per second. Now you see here, what is the problem here? Now, so if it is only one pole, if this is only minus 1, so we can write like this. If this is only minus 1, we can write like this, 1 by s plus 1. Am I right or not? If there is only one pole, we can write 1 by s plus 1. But what happened here? There is 2 poles. There is repeated poles. Therefore, there is repeated poles. 1 by, so can I write like this? 1 by s plus 1. Now, this is one pole minus 1, therefore 1 by s plus 1. But the repeated pole, therefore 1 by s plus 1 whole square. 1 by s plus 1 whole square. Now, if it is a 1 by s plus 1 whole square, then what happened? No. Then assume this is some s. 1 by s square. 1 by s square. What is 1 by s square inverse Laplace transformation? 1 by s square inverse Laplace transformation is t. Am I right or not? 1 by s square inverse Laplace transformation is t. 1 by s square inverse Laplace transformation is t into 1 by s plus a, which is equal to e power minus t. 1 by s square inverse Laplace transformation is t. 1 by s plus a means e power minus t. This is the impulse response in time domain. Now, which one point you have to be identified here? One important point you have to be noted down. That is nothing but whenever there is a t term, then this t is coming, which means that poles are repeated. The t is coming is nothing but poles are repeated. Sir, wherever the t is coming, whenever the t is coming, The meaning of that is where there is a t term, which means that the poles are repeated. If the poles are repeated, then this t is coming. Now then the question is, sir, okay, t means poles are repeated. Where it is repeated, in which axis it is repeated, in which plane it is repeated, that you can decide it from the next term. What is the next term? Exponential. That's what the first time onwards I am saying. Remember this one. So e power, what is this? E power real part. What is the meaning of that? T means repeated. Where it is repeated, then you just see the second term. E power, what is that? E power real part. What is the real part? How much is real part? E power real part into t. Real part is how much? Minus 1. Minus 1 means what? Whenever there is a minus 1 in your mind, you want to remember minus 1. Oh, which means that negative real axis. Therefore, the pole is repeated at minus 1 because this is t means repeated. E power real part. Like this. For example, let us, the question is like this. T into some sine 3t. Then what is the meaning of that? T into sine 3t. What is the meaning of that? Then you try to understand what is the meaning of that. T means what? T means, just now I am saying, T means repeated. T means poles are repeated. Where it is repeated, see the second term. Where it is repeated, see the second term. What is the second term? Sine 3t. What I am saying here? Sine or cos? Imaginary part. Imaginary part. What is imaginary part here? 3. Means imaginary part is there. So on the imaginary axis, at 3, the pole is repeated. On the imaginary axis, at plus j3 or minus j3, the pole is repeated. Like that you can easily identify. Okay. Anyway, the important here is not the response in time domain. How to draw the response. The drawing is also very important because one GATE examination, 2 marks question, match the following. One side pole's location, other side response. If the pole is left hand side, right hand side repeated, what should be the response with respect to time? Exponential increasing or exponential decreasing, or how the responses are, which is very important. Therefore, if this is the term, so finally what you can get, we can get the impulse response, which is nothing but, so some c of t, which is equal to t into e power minus t. Like this, this is the impulse response which is coming. Now you see here, now ramp signal. Now this is a ramp, the ramp signal multiplied with, this is the ramp signal multiplied with exponentially decaying. This is the ramp signal multiplied with exponentially decaying. Now this is the ramp signal and this is exponentially decaying. Now the ramp multiplied with exponential decaying. Multiplication is nothing but common area, common limits. Multiplication is nothing but common area, common limits. What is the common area, common limit? This is ramp and this is exponentially decaying. Now this is the impulse response in time domain, and this is a multiplication of, now this is the impulse response in time domain, which is nothing but t into e power minus t. And this is t into e power minus t, the combination of a ramp and exponentially decaying. Anyway, the response which is follows the input, then when given the time axis, the response is follows the input, system is stable. And is there any oscillations? Is there any sine wave or cos wave? No, there is no sine wave, there is no cos wave. Therefore, the frequency of oscillation is 0 radians per second. Then how much you are getting? You are also getting the 0 radians per second, and both are matching. Okay, then you take this one. But you remember this one where there is a t term, which means that poles are repeated, because in the reverse also it is it will be useful. Now sometimes it is giving like this. When there is giving a t term and then the poles are repeated, where it is repeated, see the second term. If it is exponential, the poles are repeated in the real axis, negative real axis or positive real axis. If it is minus, negative real axis. If it is a plus, positive real axis. Instead of this exponential term, there may be a sine or cos. The poles are repeated on imaginary axis. Okay, you just take this one. Now see here. Now the same question. Now I am giving this pole's location in the right hand side of S-plane. Then what is the answer? Then two closed loop poles, therefore no doubt order equal to 2. But the pole is lies on right hand side, system is unstable. If it is unstable, time constant cannot calculate it. Time constant we cannot find. Now, is there any imaginary part? No imaginary part, only real part. Therefore, frequency of oscillation is 0 radians per second. Now, the same thing here is also. Then 1 by s minus 2 whole square. 1 by s square means repeated t. E power real part. What is the real part? E power plus 2 into t. That's what I am saying. T means poles are repeated. Where it is repeated, you see the rest by exponential e power real part. Therefore, what should be the response? Now this is ramp and this fellow is, now that is the ramp signal and this one is exponentially increasing. Now this is exponentially increasing. But now these both are moving towards the infinity side, right? These both are moving towards the infinity side. Therefore, now the overall response is nothing but one is linearly varying, another one is increasing. Now both are moving towards the infinity side. That's why the system which is unstable. Now C of t which is equal to t into e power plus 2t. Which is unstable. Okay, then you take this one. The same. Then only one point you remember, if it is repeated, which means that the poles are, t means t term is coming, the poles are repeated. Okay, like this we will solve a few poles zeros location in S-plane, and that concept also we will see in the next session.